Alright, so we are going to start with chapter circles from coordinate geometry, and we have question 1 over here which says a variable circle having fixed radius a passes through origin and meets the coordinate axis in points A and B. Locus of centroid of triangle OAB, O being the origin is, and 4 equations are given and we have to determine the correct option. Alright, so how should we start this question?
First we take the general equation of the circle passing through the origin, which is x square plus y square plus 2gx plus 2fy equal to 0.
Okay.
If a is the radius of the circle, then the formula is a equals to root over g square plus f square.
Right, this is from your general formula where the radius is given by root over g square plus f square minus c.
Yes.
C is 0 here, so this is our equation of radius.
But the circle passes through the x-axis at point A, which is minus 2g comma 0, and y-axis at point B, 0 comma minus 2f. It is obtained like at x-axis the y equals to 0, and substituting the y equal to 0 in our circle equation, we get x equals to minus 2g.
Right.
So similarly, for the point passing through the y-axis, we'll keep the x equals to 0 and we'll get y equals to minus 2f.
Right, so these are the A and B given in the question where the circle cuts the coordinate axis.
And the circle also passes through the origin,
Right.
which is 0 comma 0. If we know the 3 vertices of the triangle, which are x1 comma y1, x2 comma y2, x3 comma y3, then the centroid of the triangle is given by x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. So if we assume the locus of the centroid of the triangle as P, H comma K, we have H equals to x1 plus x2 plus x3 by 3, which in our given question converges to minus 2g by 3.
Right.
And k equals to y1 plus y2 plus y3 by 3, which in our given question converges to minus 2f by 3.
Right.
So this implies 3h equals to minus 2j and 3k equals to minus 2f. So on squaring and adding the 3.
Yeah, so what we are seeing so far is that certain restrictions are given that the circle cuts A and B axis and the triangle OAB is given. So first we found the triangle OAB's coordinates and then we are trying to find the centroid of the triangle. Yeah. Okay.
Now squaring and adding the 3h and 3k terms, we have 9 into h square plus k square equals to 4 into g square plus f square.
Right.
But since g square plus f square equals to a square, we have written it above, we are replacing that. But the locus of the triangle should be in the terms of h comma y. So we are replacing the h comma k by x comma y. So we have 9 into x square plus y square equals to 4a square. This is our required locus equation.
Okay. So one more doubt that could arise in the student's mind is that your a is also a variable and g and f are also variables. So how would one know that you have to replace g square plus f square by a square? Why not let it be as g square plus f square?
But in the question it is mentioned that a circle of fixed radius a.
Alright.
So
okay.
It is not a variable.
Okay. Okay, so radius was already given to us and from our general equation we got the formula of radius in terms of g and f and then replaced g and f in terms of the radius.
Yeah.
Okay. Alright, so what we saw in this question was that a given circle was given and certain restrictions such as the circle cuts the coordinate axis were given and we had to find the locus of the centroid of the triangle. So what we did was we started with the general equation of the circle passing through the origin. And since radius was already given, we found out the radius in terms of our general equation in terms of g and f, and then we simply found out the coordinates of point 0 origin. We already know coordinates of point A and B, and then we found out the centroid of the triangle. And since we had to find the equation of the locus of centroid, we simplified h and k and we replaced h and k by x and y. So that is our final answer, which is option A, as you can see. Alright, so that was question number 1. Alright, so we have question 2 over here which says the equation of the image of the circle x square plus y square plus 16x minus 24y plus 183 is equal to 0 by the line mirror 4x plus 7y plus 13 is equal to 0 is 4 options are given. Let's see how to solve this question.
See, first thing what you have to understand is when we take the image of the circle, then the radius of the circle remains constant, but only the center changes. So we find the new center, and since we know the radius of the circle from the given equation,
Right.
then we can easily find that.
Okay.
So what we'll do here is first we'll calculate the radius and the circle of the radius and center of the given circle.
Okay.
Okay, the radius center of the given circle is minus 8 comma 12,
Right.
because if the equation of the given circle is x square plus y square plus 2gx plus 2fy plus c equals to 0, then the center is minus g comma minus f,
Right.
and radius equals to root over g square plus f square minus c, which in our given question is 64 plus 144 minus 183.
Right. These two are pretty well known formula and something
So
which you
radius
should
is
remember.
5.
Right. Radius is 5. So the radius will not change naturally. Only the positioning of the circle will change.
And our equation of our line mirror is
Okay. This is the equation which we have to consider as the mirror for the circle.
yes. So we'll take the image of the point minus 8 comma 12 with respect to the line. Okay. Since we have studied in the chapter straight line how to take an image of a point with respect to a given line, we'll directly substitute the formula here.
Okay. So what is the whole idea of taking the mirror image of the center? Why only the center?
Because we know that when a mirror image is taken of a circle, the radius remains constant.
Right.
So if we just calculate the new center,
Right. So we could find the equation of the whole circle.
yes,
Okay. We could even find out the mirror image of any other point, but since it would be easier for us to directly find the center, mirror image of the center, we are calculating for the center, right?
and the main thing is if we find the image of a point, but we will not be able to calculate the equation of circle from that point.
Right.
If we have the center and the radius, we have the
It's very
formula.
easy for us.
Yeah, because if you want to calculate by point, we'll get the point, the coordinates of the images, but we don't know how to
Find
calculate.
out the equation of the circle.
Yes.
Okay. So basically, all points are getting mirror imaged across the line, but we are calculating the mirror image of the center because it will be convenient for us.
Yes.
Okay. So directly substituting the formula from straight lines we have.
Where x and y are the image coordinates of the center.
Okay. Where x and y is what is to be found, the coordinates of the image.
Yeah.
Okay. Right. So solving for x and y.
Yeah. X plus 8 equals to minus 8.
Okay.
So x equals to minus 16.
Right.
Whereas y minus 12 equals to minus 14. So y equals to minus 2.
Right. These are the coordinates of the new center.
So x plus 16 whole square plus y plus 2 whole square equals to 5 square.
Since 5 was our radius of the original circle.
Now on rearranging,
Right. Okay.
this is our equation of the image of the circle.
Which matches with option
D.
D. Right. All right. So this was a pretty simple question, but a few things that you need to keep in mind is that when you take the mirror image of a circle about any line, radius remains same. Naturally, the proportions of the circle are not changing, but the positioning of the circle changes, and every point gets mirror imaged with respect to the line mirror. But since in this question we had to find out the equation of the circle. So we found out the mirror image of the center of the circle with respect to the line using the direct formula which we learnt in chapter straight lines. But you need to keep in mind that essentially every point is getting mirror imaged, and I mean, if you are given any point on the circle, say, and you are said that find out the coordinate of this point with respect to the new circle, so you could directly find out the mirror image of that point. But here we found out the center for our convenience. Alright, so that was question number 2. Alright, so we have question 3 over here, which says a light ray gets reflected from the line x is equal to minus 2 if the reflected ray touches the circle x square plus y square is equal to 4 and the point of incidence is minus 2 comma minus 4. Then equation of incident ray is 4y plus 3x plus 22 is equal to 0, 3y plus 4x plus 20 is equal to 0, 4y plus 2x plus 20 is equal to 0, x plus y plus 6 is equal to 0. Alright, let's see how to answer this question.
See, first we'll see the diagram, like how we'll see how the ray comes, how it gets reflected.
Okay.
So see, if the thing, this is the incident ray, it gets reflected at the point minus 2 comma minus 4,
Right.
and while it is going, it touches the circle x square plus y square equals to 4. So we'll start from the reflected ray. So if we take since we know that the reflected ray is the tangent of the circle x square plus y square equals to 4,
Right.
the general equation of the tangent of the circle x square plus y square equals to 4 equals to y equals to mx plus or minus 2 into root over 1 plus m square, because general equation is y equals to mx plus or minus r root of 1 plus m square.
Okay.
But since the radius of the circle x square plus y square equals to 4 is 2, we get this equation.
Okay.
But this straight line also passes through the point minus 2 comma 4, minus
Right.
2 comma minus 4. So on substituting this one, we get minus 4 equals to minus 2m plus or minus 2 root over 1 plus m square. Now rearranging it, now we'll square it.
Right. So won't there any extra solutions be coming if we square this equation?
But after while doing the question, we'll understand that one of the solution it is not possible, so we'll delete that.
Okay, fine.
So we'll cancel it,
Right.
and then we'll get m equals to 3 by 4.
Okay. Pretty easy to solve that equation. Right.
Now we know the slope of the reflected ray, but we have to find the equation of the incident ray. So if we notice here, means if this is the x-axis, and so this is the theta of the reflected ray,
Right.
and if we want to take the theta for how which the incident ray is inclined, it is minus theta,
Right.
means it is in the opposite direction, that is the clockwise direction, means it is the same value but it is in the opposite direction.
Right.
So the slope of the incident ray will be minus 3 by 4.
Exactly. Since theta magnitude is same, but the direction is reversed, so the sign
The
will
reflected
be
ray is in the anti-clockwise direction and the incident ray is in the clockwise direction.
Right. So the sign will be reversed for the slope.
But we know that the incident ray passes to the point minus 2 comma minus 4. So using the slope point form of the for finding the straight line equation, for example, which is like if it's a straight line passes through the point y1 comma x1 comma y1 and the slope of the line is m, then the equation of the line is given by y minus y1 equals to m into x minus x1.
Right. And make sure here your m is the slope of the incident ray that we are talking about here, which is minus 3 by 4.
So the incident ray's slope can be considered as mi, the reflected as mr.
Right.
So on substituting, we get y minus of minus 4 into minus 3 by 4 into x minus of minus 2. Now 4y plus 16 equals to minus 3x minus 6. On rearranging, we get 3x plus 4y plus 22 equal to 0.
Okay. And one more thing, let's give the students a little refresher on exactly how we got the slope of our incident this thing as minus 3 by 4. See, it's not like you have to remember that if the angle theta is reversed, then you get the slope as negative or positive of the original slope. We know that what is the definition of slope. Slope says that tan of angle made by the line with the x-axis. So here your angle was given as, suppose we assume it to be theta. So tan theta is nothing but your original slope, which is 3 by 4. Now if you have to find the slope of the new line, what you do is either you take tan of pi minus theta, or you take tan of minus theta, which is nothing but minus tan theta, which is nothing but minus of 3 by 4. So that's how you get the slope as minus 3 by 4. Alright, so what we did in this question was, it was a pretty simple question. If you see, certain assumptions were given that the line is incident and it touches the circle at so and so, and it touches the point minus 2 comma minus 4. What we did was, we started from the reflected ray, since we knew that it is intersecting the point minus 2 comma minus 4, and we also knew that it is tangent to the circle, the given circle. So we knew the slope of the line, and basically we knew the equation of the reflected ray. From that we derived the slope of the reflected ray, and then we worked towards finding the slope of the incident ray, and then since we knew the point of intersection, we found out the equation of the incident ray. Alright, so that was question number 3. Alright, so we have question 4 over here, which says, if the angle between tangents drawn to x square plus y square plus 2gx plus 2fy plus c is equal to 0 from 0 comma 0 is pi by 2, then g square plus f square is equal to 3c or 2c or 5c or 4c. Alright, so let's see how we'll solve this question.
See, since we know that the director circle is the locus of the points from which the angle between the pair of tangents drawn to a given circle is pi by 2.
Alright, so that was a big statement. Let's break it into parts and let's see what that means. What do you mean by director circle again? Could you explain?
The director circle is the locus of points from which the angle between the pair of tangents drawn to a given circle is pi by 2.
Okay, so the collection of all points from which if you draw two tangents to the circle, then the angle between those two tangents is pi by 2.
Yes.
Okay, so 0 comma 0 will definitely lie on the director circle according to the given question.
Yes,
okay.
But the equation of the director circle is like, to the circle to whom the tangents are being drawn, the center is the same, but the radius is root 2 times the radius of the circle.
Okay, so that is your equation of director circle.
So the equation of the director circle for in our given question will be x square plus y square plus 2gx plus 2fy.
Since the center is the same.
Yeah, 2f square equals to 2 into g square plus f square minus c. Here means x plus g whole square plus x plus y plus f whole square equals to root 2 times our radius whole square.
Yeah.
So on squaring and rearranging them, we'll get this thing.
Okay. So since you can directly find out the formula for the radius of the circle, this will be root 2 times, substitute that, and the center remains same, so you can get the equation of director circle.
We got the equation from this thing.
Right. Root 2 times of root of g square plus f square minus c. Right. Okay.
But 0 comma 0 lies on the director circle.
Yes.
So on substituting 0 comma 0, here we get g square plus f square equals to 2 into g. On rearranging, so this is the required condition.
Okay. Alright, so if you see in this question, suppose you are not acquainted with the concept of director circle, then you go about maybe you'll try to solve by finding pair of straight lines for the given equation of tangents, writing the equation, substituting 0 comma 0 and making sure that the angle is pi by 2. It will be very complicated, and since we know what director circle means and it is clear from the question that 0 comma 0 is a point lying on the director circle, we can directly find the equation of the director circle. Since we know that the center of the circle and the director circle is same and the radius is root 2 times of the given radius, directly find out the equation of director circle and substitute 0 comma 0 in the director circle and we can get the relation. So make sure you remember what a director circle means and what is the equation of the director circle. Alright, so that was question number 4.